last video, we talked about the Pythagoras theorem, which stated that if you have a right triangle, a squared plus b squared equals c squared. Well, today we're going to talk about the converse to the Pythagorean theorem. This says, if a squared plus b squared is equal to c squared, then you know you have a right triangle. So this lets you, if you're not sure if it's a right triangle, this is a test to figure out if your triangle is right and if you can use the Pythagorean theorem to solve the triangle. Okay, so in this first example, we have a triangle that has side lengths 2, 5, and 7. And then you're asked that this is not drawn to scale. Is this triangle a right triangle? So according to the converse of the Pythagorean theorem, we take the two shorter sides, which is the 2 and the 5. We square them and add them together. If we get equal to the 7 squared, then we know this is a Pythagorean theorem. So let's look. We get 4 plus 25. We're comparing that to 49. Well, obviously 29 is not equal to 49. So that's how we know that this is not a right triangle. Now, I could have saved some little work on this problem if I knew one important factor. If sometimes 3 measurements of sides cannot even form a triangle. So in order for 3 sides to form a triangle, that's any type of triangle, left, right, obtuse, acute, either one, you have to know that the sum of the 2 shorter sides must be greater than the length of the longer side. If that is not true, there's no way you can connect those 3 line segments. You're going to have a gap in your picture. A triangle be formed with side lengths 2, 5, and 7. Well, let's see. The 2 shorter sides are 2 and 5, so add those together, we get 7. And then the longer side is 7. So since 7 is equal to 7 and 7 is not greater than 7, I know that these three side lengths cannot form a triangle. So I could have used this method to prove that that it is not a right triangle. If a triangle can be formed with 3 side lengths, we can also figure out what type of triangle it's going to be. Is it going to be acute, obtuse, or right? So this middle one, c squared is equal to a squared plus b squared, tells us that the triangle is right. That's the converse to the Pythagorean theorem that we've been talking about in this section. Given triangle ABC, which its longest side is c, if c squared is less than a squared plus b squared, we know that that triangle is acute. How I remember this, I think less than is less of an angle, which is an acute angle, small angle. If c squared is greater than a squared plus b squared, then I know that the triangle is an obtuse triangle. So again, think greater than, greater angle is obtuse. And if c squared equals a squared plus b squared, I have a right triangle. Equal to is just right. Okay, for our next example, we're going to determine if the following side lengths can form a triangle and then classify the triangle as acute, right, or obtuse. Example 1, our lower side is 34, so I'm going to check and see if 16 plus 30 is greater than 34. So since 36 is greater than 34, we know we can form a triangle. And so now take the longest side squared plus the 2 shorter sides squared, add together. So let's see, 1,156 how is that related to 256 plus 900? So that's 1,156 happens to be equal to 1,156. So this first example forms a right triangle. In example 2, 5 plus 5, compare it with 8. 10 is greater than 8, so we can form a triangle. 8 squared, how is that related to 5 squared plus 5 squared? Well, 64 is greater than 50, so I know this forms an obtuse triangle. Greater than is obtuse. In example 3, I take 5 plus 8 and compare that with 15. 13 is less than 15, therefore this cannot form a triangle. In example 4, we have 4 plus 4, compare that with 5. 8 is greater than 5, so we can form a triangle. And then we got 5 squared, how's that related to 4 squared plus 4 squared? Well, 25 is less than 32, so we have an acute angle, acute triangle. 3 side lengths form a right triangle we have a special name for those three side lengths. They are called Pythagorean triplets. So Pythagorean triplets obey the rule a squared plus b squared equals to c squared. Example, we're going to determine if these three numbers are Pythagorean triplets. So I'm going to take the two smaller sides, square them, and add them together and see if it equals the longest side squared. So in this case, that's 1 squared plus 1 squared. Is that equal to square root of 2 squared? So I get 2 equals 2, so that's true. 1 square root of 2 are Pythagorean triplets, and my answer to this question is yes. The second example, we're going to see if 4 squared plus 6 squared is equal to the square root of 48 squared. So I end up with 52, which is not equal to 48. So these three numbers, 4, 6, and the square root of 48, are not Pythagorean triplets. In the last example, we have the square root of 26 squared plus 6 squared related to the square root of 62 squared. Here I end up with 62 is equal to 62. So yes, these three numbers, square root of 26, 6, and square root of 62, are Pythagorean triplets. Next two examples, we're going to find k so that these three numbers form Pythagorean triplets. So we set up the same way as we did in the last problem. We're going to take that 3 squared plus k squared is equal to 9 squared. This time it needs to be equal to. And then we're going to simplify down and we're going to solve for k as we've done in the past. So we end up with k squared is equal to 72. So therefore I take the square root of each side, and again, because I'm looking at a triangle, a geometric shape, I only have positive square root of 72. I don't have to worry about the negative. Well, I know I can simplify the square root of 72 to be 6 the square root of 2. So if k is equal to 6 the square root of 2, then 3, 6 the square root of 2, and 9 are Pythagorean triplets. Repeating the same process for example 2, we have 8 squared plus the square root of 170 squared needs to equal k squared in order for these three numbers to be Pythagorean triplets. Simplifying down and solving for k, we end up with, so k is equal to 3 the square root of 26. So the numbers 8, the square root of 170, and 3 the square root of 26 are Pythagorean triplets.